So here's the question. So it says the results of a survey given to a random sample of 2,350 people indicated that 900 excuse me, and 78 people of the 2,350 people have received flu vaccines, and wants me to construct a 99% confidence interval. And then once I do that, it wants me to use the confidence interval to comment on the belief that 45% of the vaccine eligible people have received the vaccine. So here it is, and I did MP is greater than or equal to 10. Well, that's the formula. And then I have to do N times 1 minus P hat, and hopefully that becomes greater than or equal to 10. So I use 2,350 times 970 divided by 2,350, and that was greater than or equal to 10. And then I did 2,350, and I did the formula N times 1 minus P, and that was my answer, 1,372, which is greater than or equal to 10. Well, it's greater than 10. And then I did P hat plus or minus the Z. I got 978, which is greater than 10. And then I had to do this formula, which is P hat plus or minus Z with the square root of P hat times 1 minus P hat divided by N. And which is, the P hat is 0.416, and I got that by doing 978 divided by 2,350, which got me to 0.416. So I did 0.416 plus or minus 2.576, and then I had to do the square root of 0.416, which is the P hat, which is right there for the formula. And then I had to do 1 minus the P hat times 0.416 divided by 2,350, which got me to 0.416 plus or minus 0.026, because that's what I got right here. And then when you do 0.416 plus 0.026, that gets me 0.442, and then once you do 0.416 minus 0.026, you get 0.39. So I am 99% confident that the true proportion of the vaccine eligible people who actually got the vaccine is in the interval for 0.39 and 0.442. So then the second question asks, a 99% confidence interval for the proportion people will receive flu vaccine is to be constructed. What is the smallest sample size that can be used to guarantee that the margin of error will be less than or equal to 0.02? Well, I don't know what the P hat is, so I'm going to use 0.5 as a conservative estimate, and then the margin of error is less than or equal to 0.02. So there's the formula again for the Z, and then I did 2.576 with the square root of 0.5 times 0.5 divided by N, and maybe that's less than or equal to 0.02, and then I got pretty much the N equals 4,147.36, which is less than or equal to N, and then the sample of 4,148 vaccine eligible people should go to Canada, and that's my work.